Okay, hi everyone. Today we will be doing another chapter which is called some natural phenomena. Alright, so some phenomenons or some occurrences are there that are natural in our environment. These things happen like lightning or disasters, that those things happen naturally. We call that natural phenomena. Alright, we will understand how that happens, what goes into it, how we observe it. So let's start. Lightning. Alright, lightning is the first natural phenomena that we are going to study. Lightning is a natural electrical discharge that occurs during thunderstorms. So whenever it gets rainy, there is a storm, we see lightning. Alright, if you hear that thunder, that means lightning has strike in the sky or somewhere. Okay, so lightning has occurred. That is why we hear thunder. I will tell you how. So this is what lightning looks like. We can all see. Alright, we have all seen lightning one point or the other. So it is an electric discharge. So what is it? Electric discharge. This is electricity flowing. Okay, that occurs during thunderstorms. During thunderstorm, it is a sudden and powerful flash of light caused by the movement of electrical charges between the Earth's surface and the atmosphere. So if we have, this is the surface, alright, this is Earth, this is atmosphere. Suppose there is a different potential difference. Okay, there's a potential difference between the Earth and the atmosphere. That is why electricity is able to move between that. And this is observed as a flash of light, which is called lightning. It is very powerful. It has a very high temperature. It contains electricity. Alright. Lightning is typically seen as a bright streak. Alright. We see it very bright for a few seconds. Alright. Often accompanied by thunder, and it can be dangerous. So what happens is, since lightning is very hot, alright, lightning is very hot. When it strikes, alright, in the sky, in the atmosphere, there is a sudden outburst of energy. Alright, everything starts to expand. The clouds start to expand. There is that water that evaporates. There is a sudden burst. Alright, which comes out later as thunder. Alright, so how is lightning formed? Lightning is formed due to the separation of positive and negative charges. Like we know how electricity flows, positive and negative charges, alright, within a thundercloud. So within a cloud, alright, maybe this is a cloud, there is some charge that is positive and there is some cloud which is negative. Electricity, water will flow through this, alright, electricity will flow coming out as lightning strike. So within a thundercloud, the negative charges accumulate at the bottom of the cloud, while the positive charges accumulate on the ground below the cloud. When the difference in charge becomes too great, a flow of electricity occurs, resulting in a lightning strike. So on the ground there will be some positive charge. On the cloud, at the end of this cloud, there will be a lot of negative charges, alright, and positive charges on the ground. This will result in electricity flowing, alright, electrical discharge. Example, imagine a dark, cloudy day with thunder in the distance. Suddenly, a bright bolt of light strikes across the sky like this, okay, followed by a loud rumble of thunder. Whenever there is lightning, there will be thunder, alright. Lightning can be dangerous, and it is important to take safety precautions during thunderstorms. So during a thunderstorm, it is very important to take precautions, otherwise we might get hit by lightning. And some measures are over here. Seek shelter, alright, go indoors, go to your houses, go in some closed room, alright, seek shelter. When you see lightning or hear thunder, seek shelter immediately, alright, seek shelter immediately. A sturdy building or a hard top vehicle, even a vehicle, get inside a vehicle and you will not get hit by lightning. With closed windows and doors can provide protection from lightning strikes. Alright, get inside a safe room or a vehicle or a building, alright, which does not have any open window. Alright, close it all shut. In the car, a vehicle should not have any open windows. close it all, and you will not be hit by lightning. Alright, you will be relatively safe. Avoid open areas. In open areas during thunder and lightning, alright, if there is an open grassland, a big open grassland, and you are traveling, there might be some electrical potential difference between you and the clouds above, and it might hit you. The electrical discharge might hit you, alright, and it will cause a very severe burn. It is very hot. Lightning strikes are very hot, hot like the sun, alright. So yeah, stay away from hilltops, stay away from isolated trees, cause lightning can fall on trees as well, water bodies and other tall objects during a thunderstorm. Stay away from tall objects. Don't be under a tree, alright, don't be in open areas. These areas increase the risk of being struck by lightning. You might get hit by lightning in open areas. Stay indoors. Again, if you are indoors, avoid using electrical appliances, landline phones, or taking showers during a thunderstorm. Now, why is that? Don't use electrical appliances because if it hits your building, the electricity, that electric discharge will travel through the appliances and it might give you a shock. Landline phones, it might travel through that wire of the phone, alright, of the phone, landline phones, and it might electrocute you. Okay, don't take showers during a thunderstorm. It can travel through water as well, alright, a shock. Lightning can travel through electrical wires and plumbing, alright, so you're not safe by plumbing as well, posing a risk of injury, a burn. Stay away from windows, alright, you should not be near your windows. Keep away from windows, doors and concrete walls during a thunderstorm. Lightning can travel through conductive materials. Conductive means those who let electricity pass through them, alright, electrons pass through that. And these areas may not provide adequate protection, alright, these areas will not give you much protection, it can still hit you. Wait for the all clear, okay, wait for the all clear, like let the clouds pass by, alright, when the sky is clear. After thunderstorm has passed, wait at least 30 minutes before resuming outdoor activities. Right? If there is a thunderstorm, you see lightning in the sky, it is just above you, it is advisable to not go out cause it might still hit you, okay, and they say after 30 minutes you should go out. Lightning can strike even after the storm has moved away, alright, so even after the the storm has moved away, you can still get hit by lightning. Now some lightning safeties inside the house, alright, indoors. Avoid corded phones, like I told you, avoid landlines. Do not use corded phones during a thunderstorm. Lightning can travel through phone lines, posing a risk of electric shock. So you might be talking on the landline phone, there's lightning outside, it hit the tower and it is traveled through that wire and electrocuted you. Okay, unplug electronics. Do not let anything be plugged to charge or use any electrical appliances. Unplug sensitive electronics such as televisions, computers and other appliances during a thunderstorm. This helps protect them from power surges caused by lightning. So suddenly there is an electric shock, there is a sudden lightning and it might harm your devices as well. It is plugged into the electric plug, alright, it is plugged into the electric plug. There is a plug, it might still get an electric shock and harm the device, harm the TV, harm all the devices that you have connected. Stay away from plumbing, stay away from water pipes, plumbing, water taps, showers. Avoid using faucets, showers, sinks during a thunderstorm. Lightning can travel through plumbing and cause electric shocks. So it might hit your plumbing and the electric shock can travel and hit you. Stay off balconies and porches. Avoid standing in open balconies and porches that are not properly grounded during a thunderstorm. So you might be at some height or in an open area. These do not give protection from lightning. They do not provide adequate protection from lightning strikes. Follow emergency procedures. Alright, familiarize yourself with emergency procedures of your building. See your building. How do you get out when there is something like this? Including evacuation routes. Every building has some evacuation routes. In case of emergency, how are you to exit that building? Always follow those procedures, always familiarize yourself, always study that how you can get out of such an disaster. Now we come to a lightning conductor. What is a lightning conductor? A lightning conductor or lightning rod is a device installed on tall structures. Alright, like this. This is a tall structure. Okay, this is a lightning conductor. These lightning conductors protect the building from lightning. Nowadays, all buildings have lightning conductors. So lightning will fall over here. It will travel through this path. Alright, and it will go into the ground. There will be a big conductor connected to the earth. Alright, and this electricity will pass into the earth safely without harming the people in the building and their appliances. Okay, it provides a preferred path for lightning to follow, directing the electrical discharge safely into the ground. So it came from above and we transferred it into the ground. A typical lightning conductor consists of a metal rod or a network of conductive cable. So you might have seen sometimes on roofs a structure like this, or a structure like a single rod above a building. Alright, so this is a metal rod. This is called the lightning conductor. For example, imagine a tall building equipped with a lightning conductor. During a thunderstorm, if lightning were to strike that building, the conductor would channel means transfer, it will send the electrical charge safely means without harming anyone, into the ground, protecting the structure from damage. So the building won't get damaged, the people inside won't get damaged, and it will follow this green path into the ground. Simple as that. Now, another important natural disaster is earthquakes. We all have felt earthquakes at some point in our lives. Earthquakes are natural phenomena that occur when there is a sudden release of energy in the earth's crust. So imagine inside the earth there is a lot of energy, alright, and in some place under the ground it erupted, alright, there was a crack and some energy escaped. This will result in the ground to shake, alright, the ground will shake, and it is caused by the movement of tectonic plates. So this is the innermost part of the earth, the outermost part, another outermost part, and then there is the surface. Alright, then there is the surface. This surface is made of a lot of plates. Alright, a lot of plates. These are called tectonic plates. When these plates move over one another, or they collide, they strike, then there is a earthquake. The ground shakes. Okay, these are large sections of the earth's crust that float on semi-fluid mantle below. So there are plates. These plates are floating over semi-liquid magma mantle. Alright, so that mantle is not purely solid. So something can float over it. It is a very hot liquid and something can float over it. So these plates are floating, and since they are floating, they can strike, collide over each other. This results in earthquakes. Earthquakes can vary in the intensity, ranging from mild tremors that are barely noticeable to severe earthquakes that cause widespread destruction. So every day there are a lot of earthquakes all over this earth. Alright, some are very major, some are very minor. Alright, you can't even feel them, or if you feel them, there is no damage. But in some cases, there is a very severe earthquake and it damages a lot of things. If you remember in Nepal, alright, there was an earthquake. The intensity of an earthquake is measured using the Richter scale. So every time you see there is an earthquake, they will show on the news that it measured this much on the Richter scale. Alright, that shows how intense was it, how much damage did, how powerful was that earthquake, which assigns a numerical value. It will show you a number that this earthquake was of this much Richter. Alright, so based on this seismic waves, earthquake travels in the form of waves. Alright, in the form of waves. It is a transfer of waves across the land, and these are called seismic waves generated by the earthquake. So this number scale, the Richter scale, ranges from 1 to 12, 1 being the least powerful earthquake, 12 being a most powerful, most devastating earthquake. For example, picture a scenario, picture a place where the ground starts shaking violently. The ground that you're sitting on, standing on, it is shaking very fast, alright, causing buildings to sway away. Since buildings are also on that ground, they are moving, alright, they are swinging, they might break, and objects are falling, alright, everything that is on the wall, on your desk, everything is falling. People rush out of their homes, people leave their homes. Why? Because the roof might fall on their head, seeking an open place for safety. So in lightnings, we do not like an open space, but during earthquakes, we rush to an open space. Why? Because there is nothing that will fall over our head, nothing will collapse over us. This is a typical occurrence during an earthquake. Alright. The seismic waves are those waves that are produced by tremors. Alright. Tremors are earthquakes. Earthquakes can be called tremors. On the Earth's surface, earthquakes are on the surface. It's a surface phenomenon. These waves are recorded by an instrument called seismograph. So to measure these waves, I have something called the seismograph, and this is the seismograph. By studying the seismic waves, scientists can construct a complete map of the earthquakes and also calculate its power to cause destruction. So using this instrument, I can make a map of this earthquake. Where all did it hit? How far did it go? Alright, how much intense was it? And how much destruction has it caused? I can use this. Whenever there's an earthquake, this needle will start fluctuating. Alright, the harder the earthquake, the larger the fluctuations. Alright. Now we come to tsunamis. What are tsunamis? Tsunamis are large ocean waves triggered by underwater disturbances such as earthquakes, volcanic eruptions, or landslides. So now there is land under that sea as well. Alright. If there is an earthquake under the sea, supposedly this was the earth, ground, there is a lot of water over it, this is the sea, and this part gets some seismic waves, and there is an earthquake under the sea. This will send a long wave across the sea in different directions, and it will also hit the land. So over here you can see these are waves that are bigger than buildings. Alright, a really big wave caused by earthquakes, and these can cause a lot of damage to our cities, to the places, to humans. And not only earthquakes, volcanic eruptions also shake the ground, landslides, these can all cause tsunamis. When the disturbance occurs beneath the ocean floor, it displaces a significant amount of water, leading to the formation of powerful tsunami waves. Now supposedly you jump into a swimming pool. Alright, you jump into a swimming pool, what happens? There's a splash of water. Alright. Similarly, when there is an earthquake or a volcanic eruption underwater, there's a huge splash, and that huge splash is in form of waves, and these waves are very big. Alright. Tsunamis can travel across entire ocean basins as they approach shallow water near the coast. Their height increases dramatically. So when there is the earthquake, supposedly over this point, this won't be a big wave, but as it moves towards the coast, or towards the beach, towards the coast, towards land, these waves start becoming more and more big. Alright, hence when they approach land, they are very big. These waves can cause widespread devastation. Devastation means destruction, damage, alright, along the coastal areas, including flooding, destruction of infrastructure, and loss of life. So the only way you can save yourself from a tsunami is evacuate that area, go away from that place, because there is nothing stopping a tsunami. Alright. Imagine a peaceful coastal town suddenly being hit by a massive wall of water like this. A big wall of water which is bigger than buildings and all, bigger than houses. People are caught in this powerful force of tsunami, causing immense destruction. People lose their lives, people lose important structures due to tsunamis. Alright, so that is all in some natural phenomena. Thank you.